Champaign County Agriculture Today with your host, Dennis Riggs.
Hello and welcome to Champaign County Agriculture Today. My name is Dennis Riggs, your host for the next half hour as we explore some topics of agricultural interest, but more importantly of consumer interest to you here in East Central Illinois. Today we have a topic that I think that everybody has the phrase that everybody talks about the weather, but nobody does anything about it. Well, a big component of that weather is the wind. It's something that you really don't see. It's around us all the time. But now, through the use of technology and, of course, using our rural areas, wind energy to power our grid is a very important new emerging technology. We're going to talk about that today, and we've got a couple of great panelists that are with us today. Let me introduce those to you. First, Gary Van Gordon from Eastern Illini Electric Cooperative. Gary, thanks for being with us today. Give us a little bit of a background of where you're from and how long you've been with the cooperative.
Right. Well, how far back do you want to go?
Well, within prehistoric times would be too far.
Well, I was born in northeastern Pennsylvania. It's not quite as flat up there as it is out here. We have a lot of mountains. But I think my first encounter with agriculture was stepping on a cow patty in my neighbor's dairy barn one day. But we lived in the country and we did raise crops, corn and chickens and so forth and so on. But that's my agricultural background. Now, with the co-op, I've been with them not quite 8.5 years. Prior to that, Army Corps of Engineers, and then I was in the United States Air Force for 20 years. As far as background with wind, I got into that more when I get into the co-op because I need to promote this because as a cooperative, we're member owned, we're not investor owned. So we see our customers, the value that we can provide to our rural customers as preeminent. So we need to give them the most quality electric and other services that we can provide to them. That's one of our goals. So that's sort of my background and probably went too far.
Good. We're going to look forward to our conversation with you today.
Great.
Also on our panel today is Brad Yukin. Brad is currently manager of the Champaign County Farm Bureau right here in good old Champaign County. But Brad has some more background that he can bring to the table as far as wind energy. Brad, where are you originally from and tell us your background?
Well, Dennis, it's a pleasure to be here. I'm originally from the Champaign County area, the Flatville area, so a little farther north here of Champaign-Urbana. Grew up on a farm, graduated from Illinois State, and been with Farm Bureau ever since. And my interest in this topic today does stem from some past experience. I was manager of the Bureau County Farm Bureau up in the Princeton area when one of the first wind energy farms in the state of Illinois was proposed, and went through those hearings and was part of that discussion about that with the elected officials up there of getting that approved.
Great. Well, we'll look forward to hearing your perspective as far as somebody that's already been through the process of getting some wind energy going. Well, let's quit blowing the wind here and get right to the meat of the subject. Gary, I'd like to get a basic definition when we talk about wind energy. The wind is with us every day, mostly. How is it defined, and how do you look at it as a possible power source?
All right, well, very, very simply, wind energy is the earth is heated by the sun. The warm air rises, cold air moves in to fill that void, and as it moves in, it flows in there, so it's an airflow. If you hold your hand up in front of your face and you're blowing it, that's wind energy. You're blowing air through there, and that's the simple definition for it. It can be very, very strong in different areas geographically in the country. In Illinois, we are number 16 out of the top 20 states in the United States that have a viable wind energy source.
Now, that's the state in general or Central Illinois? How is that rated?
It's geographically separated, various parts of the state, and not all parts of the state are equal when it comes to the amount of wind that can be provided.
Mm-hmm. Well, Gary, when we talk about wind energy, and we've talked about other energy problems and solutions on this program, there's kind of a trade-out, or there's something utilized or something replaced. In wind energy, that's not necessarily the case, is it?
If you're talking about when you have to refine something, you have to take something out of the ground and refine it. With wind, that's not the case. It's a renewable energy source. It is very clean. It's environmentally friendly. There's a lot of good things about wind. One thing you got to remember, though, that it is an intermittent source of energy. provides, it's approximately 34% efficient. That means it really only operates about 34% of the time. So you have to judge your climate, your weather when you're planning for energy in your grid. And there are certain times you can take that energy in, certain times you can't. Typically, wind is not available in very, very hot days, and that's when you need the extra energy in the grid. So you have to kind of work around that, so it's not a good, what we call peaking tool or peaking generation system.
I wonder if there's been any research done, and I could provide the site for this. In my 114-year-old farmhouse down in southern Champaign County, in the wintertime, when the wind blows, I could use a little electric energy. I am on an Eastern Line electric grid, and we use a groundwater heat pump in addition to supplemental heat also. In the wintertime, is there an advantage to a windy day and the demand for electricity?
Depends on what, if you're talking about selling energy, a windy day, yeah, there's an advantage to that. Utilities typically they're power buyers. So the more energy that's developed with these wind turbines, the more power they can buy from that particular part of the grid. In your case, small farm, you've got a lot of energy there. They do manufacture small wind turbines, anywhere from 1,000 kW up to actually 50,000 watts. 1,000 watts up to 50,000 watts of energy can be produced from these. A little company in Oklahoma called Fergie's, or Bergie's, and they actually manufactured for residential use and small farm use.
Cool. Oh, let's talk about.
I do want to add to that. I think to one of the things I think you have to keep in mind, I think there's really two things you need with wind energy, and that's consistency and velocity. And that's why when we talk about some of the, Gary mentioned some of the farmer-owned ones or ones that are single ones on your farm, when you're talking larger scale projects, they spend years putting up test towers up there to make sure that consistency and velocity is there, because this is a large investment, which I'm sure we'll probably get into later, the investment and cost of this. But again, consistency and velocity are the two main things you need out of wind to make a project and to make a wind tower profitable.
And that was a question I wanted to bring to you, Brad. I'll come right back to you. Up in that area in Bureau County where the wind turbines have already been running for how many years has it been?
Well, it's been, the project started probably 4 or 5 years ago, and it's been a little less time since they've been up and running, but they have been operational. They've got about 33 wind towers up there, or wind turbines up there operating right now.
Well, let's just show folks what we're talking about here. Let's go to our slide number 1. And in slide number 1, we've actually got some pictures from that area, which will be fun to look at. That is the Crescent Ridge Wind Farm. And we're showing here, well, Gary, you explain to us what is actually in the slide there.
Well, this one is just the introductory slide, but it has one of at the top, actually, one of the towers. Those towers are the tower itself is 256 feet tall. From the tip of the blade to the base of the unit is 341 feet. So those blades are roughly 125 feet long. And that's a 1.65 megawatt wind turbine. They cost about $1 million per megawatt to install. So you've got about $2 million in each one of these towers. There are 33 of them up there.
Let's move on to slide number 2 now. And Brad, I want you to explain a little bit more about this one. This more or less gives the background of the demographics of the Bureau County one. In this slide, explain those 4 bullet points there.
Well, basically, the wind turbine and the wind farm that was put together was up in Bureau County, which is up on just south of Princeton, Illinois, which is on Interstate 80. So if you're familiar with Interstate 80, that gives roughly the geographic area. As far as the terrain, it's a relatively flat but slightly rolling terrain up there. A little bit different, slightly different than what we have here. Again, a little bit more rolling. There are 33 wind turbines up there, as Gary expressed, and they're producing 1.65 megawatts each. That's not total, that's each, and then totaling about 54.5 megawatts annually. So it is a larger project than initially than what a lot of people have seen, but though this has been outpaced in many cases by other projects that have many more wind turbines on them. So,
Well, I've got to say, I was up, what is the state route that is just to the west of this farm? Is it 115? I can't remember exactly what the 47. There's a state route that runs just a mile or two to the west of this
Right.
farm. And I had the advantage of driving up there the other day on another subject and went past this farm. And wow, what a tremendous looking array of the turbines going around, and it's just fun to watch. It was great. So Gary, I'm going to bring up slide number 3 now, and we're going to once again talk about energy and how much is used. Give us a little bit of an idea of the background here between the energy and how much is required by these turbines to run.
Sure.
And what we've got there, the slide actually says that there's enough energy generated to power, what, 18,000 homes? Is that correct?
About 18,000 average-sized homes, and it would be in our service territory. We cover approximately parts of 10 counties, and that size of a home would be roughly 1,500 to maybe 2,500 square feet, we'll say, as an average home in our territory. So we could actually serve about 18,000 of those with that wind farm itself. That's equal to more than 80% of Eastern Illini Electric Co-op's total usage for the year. So it's a pretty large amount, 54.5 megawatts.
A lot of electricity there. Well, let me get something straight here for folks that are listening. Some of our folks listening may be on the Eastern Illini Electric grid. They may be getting their power from somewhere else. You might explain, is this something that the cooperative is wanting to do, is looking at doing, or what's the progress there?
Well, there are several ways of helping your customers who choose to be environmental stewards to be able to do that. Our particular co-op, we do not have a wind farm. We don't own a turbine, but what we do is we provide what's called renewable energy credit certificates for any person in our co-op, or really it doesn't even have to be a member of our co-op. It can be anywhere in central Illinois or anywhere that can hear us, the sound of our voice. If you want to participate in providing wind energy and development of it, you can buy these certificates. They're not that expensive. You can buy them in 200, 300, and 400 kilowatt blocks. I think it's the $6, $9, and $12 a month is all it costs. And how we use that is 2/3 of the money we collect, the co-op collects from that, goes back to wind development, goes back to the developer. 1/3 of that goes for our administrative costs and additional marketing and promotion costs. And that's one way that we do that. Other co-ops are doing things differently. I mentioned earlier Rural Electric Convenience Cooperative down in Auburn, Illinois. They've actually purchased a 1.65 megawatt wind turbine, just like you saw in the slides there. They went at it in a direct manner, which is fine. As I mentioned before, co-ops are member-owned, so the members have to determine if they want to proceed with a project like that, because they are not cheap. The wind is free, but it's not cheap to build the turbine. So,
Of course, on the farm for many years, the windmill on the farm has been I don't know, you see a lot of pictures, and that's what everybody likes to see is the windmill on the farm. So farmers have been a user of wind power for many, many years. But as slide number 4 is going to show us, this isn't your grandpa's windmill. This is a totally different setup. So we can go to slide number 4. Tell us what we're looking at there.
well, what you're looking at there is a bunch of people standing around going, wow, because this turbine, this rotor, the hub of that rotor weighs, just the rotor, the hub itself weighs approximately 12.5 metric tons. So not a small deal. Each of those blades are about 125 feet long. There's 3 of them. Yeah, and that escapes me what the weight of those are. It's pretty heavy, let me tell you. But they're manufactured using composite materials, fiberglass and carbon is what they're made from. And a lot of composites are used in the auto industry and the aircraft industry today. So they're very, very durable, very strong.
Now, this picture that we're looking at, was this during the construction process? Is it being repaired? What's going on here?
Actually, this this rotor is ready to be mounted on top of the tower. What they did up in Bureau County was they had a staging area where they had all these blades lined up for, I forget how many acres, covered just the blades. Then they would assemble them there at that spot, transport the entire rotor and hub up to the site, the tower where they were going to install it. So this is just a part of that process. This is on the site and it's ready to be raised into place.
Okay, we're going to move ahead to slide number 6, and what's intriguing about that is that it shows the inside of the tower. Many times we think about these as being a solid structure. Explain what we're looking at here.
All right, this is, as you said, it's the inside of one of the tubular towers. They're constructed of steel, and you can see that if you look at the top of that slide, you can see that ladder. When the tower is raised, of course, that's going to be vertical. That's only one section of that tower. I think there are, and correct me here, Brad, if I'm wrong, you might know this, I think there's 6, well, divided into 256.
Mm-hmm.
And you see how tall each one of those tubular portions are. Some of this, the inside contains the electronics that run to the ground, underground to the power lines, to the transmission line, which is in proximity to the wind farm itself.
Very good. Well, let's go away from the slide for just a second and let's ask a question. So you've got this big blade up in the air, and we've all seen the pinwheels that you hold out the window when you're going down. The kids run those, and the wind makes the blade of the pinwheel turn. Basically the same process here, but how does it turn that turning motion into electricity?
Well, the rotor itself turns a shaft inside of the nacelle, which is, if you think of an airplane, the nose cone of an airplane, that's called the nacelle. So inside that cone is all the gearing. It has a gearbox in there. It has a high-speed shaft, which is turns the generator, low-speed shaft, which turns the rotor itself, and the rotor turns that shaft. That's how it goes in and it turns all that gearing in there. Then, of course, the generator supplies the power to the power lines, which, as you saw in that previous slide, run down the inside of that tubular tower and out to the transmission lines.
Most of us in our homes are familiar with 110 volts in the wall that we plug in, and 220 like our electric range or our electric clothes dryer plugs into. What type of electricity, what's the voltage that these produce?
Well, the transmission line takes voltage in 138,000 volts, or it could be 69,000, 138,000, and it goes up from there. And I don't recall what the actual size of that transmission line is. By looking at it, I think it's probably 69,000 volts.
So this is producing a high voltage load, or high voltage supply that then is transmitted and put directly out on transmission lines, just like a coal power plant or nuclear or whatever would produce.
Exactly.
Brad, I'm going to ask you, it looks like it takes a lot of ground to make this all work. What was the response from the local farmers, the local townspeople, when this type of project was being built?
Well, Dennis, I'll answer that, but I'll go back to Gary's answer first. I think I talked about earlier that you need consistency and velocity of the wind. I think the other thing that you'll find with most of these wind farms is that they're also located close to the main power lines, not just the power lines that we see running across the rural areas, the smaller lines. We need the main power lines so that these can be transmitted greater distances, because those simply just, the local ones that we see that supply your house, Dennis, where you're at, just don't have the capacity to handle this type of electricity that's created. As far as the farmers and agriculture, how they were accepted, in general, each tower takes in about 1/4 of an acre to half an acre of footprint. Those are rough numbers per tower, and so if you're talking 3 towers, you're talking an acre or less probably, or an acre and a half. And then there's a road that is connected to each one of these. Not all of the 33 wind turbines in Bureau County were connected with a single road. When I say road, a gravel road, so that they can get to these for maintenance, so some guy can climb up that ladder and get to the very top. So they would try to link 3 or 4 of them together, upwards of 6 of them together at a time. But in general, back to your specific question, agriculture was pretty well receptive to it. much as any issue, Dennis, there were individuals that were not too excited about it. But as far as the landowners that had them proposed on their property, they were very excited about it. In Bureau County, the individuals, and this varies, as Gary and I were talking earlier before the show started, the contracts vary with these individuals and the leases. The company that proposes these owns the tower, and they simply lease this small footprint, that half-acre, quarter-acre footprint from the landowner. And in that case, I know individuals that had upwards of 9 towers on their property, and they were getting $5,000 a tower per year. So that calculates, if my math is right, is $45,000 a year, and they had a 20-year lease signed. So you can start calculating the math for that size of reduction in acreage was very minimal for $45,000 a year. They felt was a very good deal for their kids' education and their general diversification of their farming operation.
Great. We're going to move ahead to slide number 7 because, Gary, we want to prove that you are actually there on site with this. Good. And when we take a look at slide number 7, we actually see, to get a picture of you and the tower there in one spot, this is a good chance for you to tell us who builds these. Is this you don't go down to your local hardware store and buy the materials here to build this. Where do these actually come from?
You mean the actual
manufacturer? Yeah.
These particular ones, I believe, were built in overseas in Denmark. General Electric has a marketing and site for these. General Electric actually has now a tower that is 3.6 megawatts. So that's probably the largest one that I know of right now for these types of things.
That's a good place to ask, how has that technology changed? Brad, that project started, what, 4 years ago or so?
Yes.
Gary, how has the technology in this type of generation changed in the last 4 years? Has it?
Oh, it's absolutely has changed. The turbines you see off of Route 39 there, just below LaSalle, Peru, they didn't have quite the capability of catching the wind with those blades as this one does. This one, they can actually tilt the blades and change the direction of the blade of the whole rotor system on top to catch the wind. The ones on 39 catch the wind, but it moves pretty much as the wind directs it. So there's more technology available, and there's going to be more and more technology as we get further along with this, so that they'll be able to generate electricity at lower wind speeds than what they do now. It's typically 7 miles an hour. Below 7 miles an hour, you don't get very much energy out of it. Your average miles per hour needs to be between 11 and 13 miles an hour to be effective.
A question that comes to my mind then, here in Central Illinois, many times we hear 30-mile-an-hour winds, gusts to 50. Tell me about what happens in a wind farm when that happens.
Well, there's actually a brake on that system, which they can slow that turbine down and actually stop it if it gets to winds that are going to destroy the system itself. So it's pretty simple technology. It's simply a brake that they apply to it, and it slows it down. Now, it may be done electronically controlled, I'm sure it is. But
Brad, since a lot of these projects are happening in the country area, have you heard of other areas? I know you're very familiar with Bureau County. Are there other areas in the state that are also looking at this?
Well, there is, Dennis. There is. The state has a large map of the state of Illinois, as you can imagine, with areas that they believe there's sufficient enough consistency and velocity to do this. It's been in the news. It's been a month or so now, but even as close as McLean County, there are areas that area is looking. The Gibson City area is looking at doing a larger wind turbine project in there. But also, as small as the University of Illinois is doing some project where they're going to erect 3 towers on the South Farms, which has been here in the news here a little bit lately. So it is close to us. It's not just some place where you have hills. We do have enough wind here, and if students have walked across campus, many a times they can know that it can get very frigid out there.
Absolutely. Well, Gary, I'd like to ask you, as a co-op looking at different ways to generate electricity for its members, what does the co-op think about the advantages of wind energy? What do you see as the advantages there?
Well, the advantages of wind energy, of course, are pretty obvious there. It's a clean energy. It's free energy, but it does cost something to do. It's non-polluting, and in a lot of cases, it's very reliable at smaller speeds in the higher wind areas of the state. Along with advantages, you got to talk about disadvantages also. And a lot of people these days, they complain about, they say, hey, we don't want to put up a wind turbine because it's going to kill birds. A study I read recently said for every 10,000 birds killed by humans in their ignorance or whatever, one is killed by a wind turbine. Mm-hmm. Now, that doesn't mean you just go out and set the turbine up anywhere. You have to have studies done. You have to look at migratory patterns of birds and so forth. So you have to be very conscientious of the environment, and that's a disadvantage that a lot of people think about. As far as wind energy goes and other types of energy, it's not going to be just wind energy that's going to be the cure-all, end-all to our energy problems. You're going to have a combination, a mix of everything to take care of the situation as we have it today. You're going to have, and nuclear is going to have to be a part of that too. Mm-hmm. And I know a lot of people don't like that word, nuke, but they are going to have to be a part of it too. If the French can generate nuclear power, 80% of their nuclear power with nuclear, I think we could probably do pretty well with it too. But I don't know if I've answered your question.
Well,
but
your point is well made. It's a mixture. It's several
Yes,
different things to
absolutely.
work together.
Absolutely.
And the wind, while it's there, when it has that consistency that we've talked
Absolutely.
about and the velocity, it looks like a very
important part.
environmentally friendly way to go. What is we talked about the U of I being a project here. As an electric co-op, are other co-ops thinking about this? Is there something going on as far as one being built from your perspective from different co-ops?
The only one right now that I know of is the one that was built in Auburn by RECC. I don't know of any other co-op that's planning to actually build a wind turbine at this point. That may change, depending. There's a lot of grants and funding out there for this right now, so that could be.
I know most of your members in Eastern Line Electric live in rural areas. What about the efficiency of an individual farmer or farm, or maybe even a small town putting up their own single unit? Is the efficiency there yet?
Again, you can get wind power, you can get electricity from any turbine, but the economy of scale is typically 20 turbines to be economically feasible.
So it sounds like it's not quite ready for the one in the backyard as of yet, but maybe soon.
One of these days.
You never know. Once again, as we appreciate both of you gentlemen being with us here today and bringing your unique perspective to this. Another solution as we look at ways that agriculture, rural areas can be an answer to the problems. And that's why we enjoy you listening with us here today on Champaign County Agriculture Today. We hope you've gained something through this program, and we hope that you've learned a little bit more about agriculture and how it can be a part of our lives every day. Tune in again next time when I, Dennis Riggs, bring you this program. Thanks for listening.
Champaign County Agriculture Today is brought to you by Champaign County Farm Bureau.